So in our previous video lesson, we learned about how to write the electron configuration of the chlorine atom, which is the 17th element on the periodic table. We made mention of the fact that the chlorine atom is a neutral atom, and in that neutral atom, the number of electrons is equal to the number of protons, and the number of protons is the same as the atomic number. In today's video lesson, we'll be talking about the ion of the chlorine atom, specifically, which is an anion. You realize that in order for chlorine to be fully filled from the main electron configuration, that is our recent video lesson, one extra electron was needed in order for the valence shell of chlorine to be 8 or to be fully filled, in order for it to obey the octet rule. So the chloride ion is a chlorine atom that have accepted one electron for its valence electron to be 8. In other words, in order to attain an inert gas electron configuration or to obey the octet rule. So from the diagram below here, we can see that we have chlorine atom here. The first shell is taking 2 electrons, the second taking 8, making 10, and the last one taking 7, making 17. So chlorine gains an electron, 1 electron. You see the electron here that's indicated by green color. So this chlorine atom has gained another electron, or a different electron, an electron from a different atom indicated by the green color, to become a chlorine ion. That is a chlorine atom that have gained an electron. So we have the chlorine ion, or the chloride ion. Okay, so today we are going to learn how to write the electron configuration of the chloride ion. Let's proceed to the board. Okay, so the chloride ion electron configuration. So now we have our chlorine, which is 17, and this one has borrowed an electron, meaning that this chlorine is having one more electron. Okay, so we have one more electron, making the number of electrons there 18. Take note of that. So let's see. So we've learned that we have the 1s orbital followed by the 2x, right? Each s orbital will take a maximum of 2. So 2 out of 18 remaining, we subtract 2 from 18 to elevate 14, right? Okay, so let's move on. So from the 2s, we move on to the 2p, which will also take 6. It is degenerate, so making 10. Then we move on to the 3x, which is also take 2, making 12. Then from there we move on to the 3p, which will take a maximum of 6. We'll elevate only 6, so we have 6 plus 2, 8. 6 plus 2 plus 2, 10, plus 8, 18. So this chlorine atom has accepted an electron indicated here as the dash, the negative. So we have 18 electrons in there, and this configuration is obeying the octet rule, and it is more stable than the chlorine atom itself electron configuration. So let's proceed by adding the expanded, the Bose notation, and the neon core configuration as well. So the expanded, you have 1s2, 2s2, 2px, right? It is degenerate. 2py, 2pz. Each will take a maximum of 2. So 2, 2, 2. Sum up to give us the 6, right? Yes. Then we have the 3s, which will take 2. We have the 3px, 3py. We have the 3pz. So this will take 2, that will take 2, 2. So 18 in number. So this is obeying the octet rule. Okay. All right. Let's proceed to the Boss notation. The Boss notation. We have 1s, draw a boss, 2x, 2px, 2py, 2pz. So degenerate. Then we move on to the 3x, then 3px, 3py, 3p of 3pz. Okay, divide them. All right, so this will take a maximum of 2 electrons. So we have spin up, spin down, spin up, spin down. So this is degenerate. So you fill them with singles, spin in the parallel before pairing begins in the opposite direction. Spin down, spin down, spin down. Then we have spin up, spin down. Another degenerate. So spin up, spin up, spin up. Then we pair in the opposite direction. So spin down, spin down, spin down. So this is how we write the electron configuration of the chlorine ion. Okay, the chlorine ion. So let's add the neon core configuration and then we end there. We learn from the chlorine atom configuration that when we are talking about neon core configuration, we have neon core, we have helium core, we have argon core in that order. Now, and I made mention of the fact that when we are talking about a core, we're talking about the inner electron configuration. So if we are using neon core, it means that neon will occupy the first the first 10 electrons, or that is the inner electron configuration. You get a point? Leaving the outer electron configuration. So if we are using argon core for a specific atom, then it means that the argon is going to occupy the configuration, the inner configuration of that atom, leaving only the valence configuration. So look at this. Chlorine, the inner or the core configuration starts from the 1s and it will end on the 2p, or let's say principal quantum number 1 and then end on the principal quantum number 2, which is the second shell. So the third shell is the valence shell or the outermost shell. Yes, so take note of that. So meaning the orbitals in the valence shell, which is principal quantum number 3, become the valence orbitals. So that is what will be the outward or the outside orbitals. Let's take note of that. So neon will occupy from the principal quantum number 1 to the principal quantum number 2. So let's see how that one will be. So we have neon here, right? Then from there we have 3x, okay, which will take 2, and then from the 3s we have 3p, which will take 6. So in all we have 18 electrons. Don't forget that neon will occupy only 10. That is the inner, that is from the 1s to the 2p. Let's take note of that. So this is how you write the electron configuration for the chlorine ion. Stay blessed and stay tuned for more video lessons.